In this lesson, we are going to cover the first part of sine and cosine. So in the last two lessons, we have been talking about tangent. So given an angle, we can find the ratio of the opposite over the adjacent, or given an angle and an opposite, we can find the adjacent side. These two other ones, sine and cosine, are, we use these if you're given the hypotenuse instead. So this is just another way of using to find a missing side, only now we can incorporate the hypotenuse. So in this lesson, we're going to express sine, and on your calculator, it's S-I-N, and cosine, and on your calculator, it's C-O-S. So we're going to express the sine and cosine ratios of given angles as fractions or decimals, and then we're going to use sine or cosine ratios to find missing lengths and right triangles. So what we're going to do here is exactly what we've been doing with tangents, only now we're going to use sine and cosine. So sine here's on your calculator, and then cosine is here. So it's sine, cosine, and then tangent. They're all three here together because they all basically perform the same function. It just depends on the information that you have been given. So the sine ratio, remember the tangent ratio was opposite over adjacent, okay? The sine of an angle is the ratio of the length of the opposite side over the hypotenuse. Okay, so tangent was opposite over adjacent. Sine is opposite over hypotenuse. So for example here, if we do the sine of angle A, okay, the opposite side is A, and then the hypotenuse is going to be C. So we would put A over C for sine. So for example here, if we want to list the ratio for the sine of angle A, okay, we're going to list opposite, that's 4. So we would put 4 on top, and then the hypotenuse is 5, so we would put 5 on top. Now, if we wanted to do B, it's opposite over hypotenuse, so it would be 3 on top, and then it would be 5 on the bottom. Okay, so that would be the way that we do sine. Now, cosine, okay, cosine is adjacent over hypotenuse. So we want to do the adjacent side, right? That's the leg that's not the hypotenuse, and then we want to put it over the hypotenuse. So for example, for this one, cosine A, all right, the adjacent side is going to be B, and then the hypotenuse is going to be C. So for example, the cosine of angle A is going to be the adjacent, so that would be 3, and then the hypotenuse, which is going to be 5. And then the cosine of B, adjacent, is going to be 4, and then the hypotenuse is going to be 5. All right, now the way that we remember this, okay, is think of it kind of like an Indian word. We say Sokotoa, okay, so if you can remember that, it's pronounced Sokotoa. All right, so, okay, that would stands for sine. Sine is opposite over the hypotenuse. Okay, that's your first one. So sine is opposite over hypotenuse. That would be cosine, is adjacent over the hypotenuse. And then toa is tangent, is opposite over the adjacent. Okay, Sokotoa, Sokotoa, Sokotoa. Just remember that. And that will help you remember which one you need to use, because we're going to get into, depending on what two things you're given, right? If you're given the opposite side and the hypotenuse, then you're going to have to use the sine function in your calculator. If you're given the opposite and the adjacent, then you're going to have to use the tangent. If you're given adjacent and a hypotenuse, you're going to have to use the cosine. So on this one, we're just going to determine the sine and cosine ratios of both of the acute angles, all right? So let's do the sine first, okay? So remember our terms here. Sokotoa, all right? So sine is opposite over hypotenuse. So the sine, okay, we're going to do sine of angle M, and then we're going to do sine of angle K, all right? Because those are our two acute angles. So the sine of angle M, okay, we're going to do opposite over a hypotenuse. So opposite then is going to be 20. And then over the hypotenuse, okay, the hypotenuse is going to be 29. So we have 20 over 29. Okay, and then the sine of angle K is going to be opposite. Okay, so that's going to be 21. And then again, the hypotenuse is still 29. So that's going to be 29. Okay, now they want us to have, now they want us to do the cosine of both of these angles, cosine of angle M and cosine of angle K. All right, so if we look up here, cosine is adjacent over hypotenuse. So we're going to find the cosine of M, okay, adjacent, right? We know hypotenuse is 29, right? That's the hypotenuse. That's going to stay the same no matter what. So if we look here for angle M, the adjacent angle, the other one that's next to it is 21. So that's going to be 21 and then over the hypotenuse, which is 29. And then the cosine of angle K, right? We know 29 is the hypotenuse, so adjacent is going to be 20, and then hypotenuse is going to be 29. So these would be the sine and cosine ratios of both of the acute angles. So here we want to find the length of R, okay? So we're given an angle and we're given the hypotenuse, okay? So what we want to do, okay, let's write up R here, SOHCAHTOA. All right, so we're given an angle, right? So we want to know, first we have to figure out, do we want to use sine, cosine, or tangent? All right, so here we have an angle. If we want to find R, where is R located? R is located opposite, right? So we have opposite, and then we're given a hypotenuse, okay? So if we look up here, the one that uses opposite over hypotenuse is sine. Sorry, I keep hitting my pen right there. So we're going to use the sine function. We're going to say the sine of 48 degrees is going to equal the opposite, which in this case is R, over the hypotenuse, which is 16.32. Okay, so now we want to solve for R, and then we can put this into our calculator. So if this is being divided by 16.32, so we're going to times this by 16.32. So R is going to equal sine 48 times 16.32. So we're going to go out here to our calculator. Okay, and again, as a reminder, make sure you press mode, right? And you want to make sure that you're in degree mode, all right? So now we have the sine of 48 degrees times 16.32. And that's going to give us basically 12.13. Okay, so that would be our, that's going to be the measure of R. It's going to be 12 point, that's going to be this side, 12.13. Okay, this says, assuming that AC is tangent to circle B, what is the measure of the radius of that circle? All right, now it's important that they told us that this line is tangent because we know when a tangent hits a radius, it hits it at 90 degrees. So that tells us it's a right triangle. So again, we're going to write our little mnemonic up here, SOHCAHTOA. All right, now we have the angle is 32 degrees. Okay, if we want to find the radius, that's X. Okay, that's opposite, all right, and then the other one that we have is 5 right here. So if we look, 5 is not the hypotenuse, so that must be the adjacent side. So what that means is opposite over adjacent, that means that we're going to have to use the tangent. Okay, so that means the tangent of 32 degrees is going to equal X, right, because that's X is opposite and then 5 is adjacent. So here we can multiply both sides by 5 to get rid of the 5. So we're going to have that X equals tangent 32 times 5. So we're going to go out here to our calculator and we're going to say the tangent of 32 degrees times 5. So the radius is going to be approximately 3.12. All right, on this one it says, given that KM is perpendicular bisector of chord ON, what is the length of LM? All right, so on here, okay, what we can find out, if we want to find out LM, we can look here, right? It tells us that KL is 4. So we know KM is a radius, right? So if we can know what the radius length is, then we can take that number and subtract it from 4. So in order to do that, if we look here, we have this hypotenuse, right? Let's label that X. The hypotenuse is also a radius, right? Because it's a line that's connected to the center. So if we can find the hypotenuse, we know what the radius is going to equal. So here we want to find X, all right? So if we look here, okay, again, let's write up our, how we remember this, SOHCAHTOA. All right, so now if we look here, angle K, all right, we have the adjacent, okay, we have an adjacent side, right, that's next to it, and we have a hypotenuse. All right, so if we have an adjacent and a hypotenuse, that means we're going to use cosine. So we can write this as the cosine of 58, okay, has to equal the adjacent over the hypotenuse. So that's going to be 4 over x. All right, so this one's going to require just an extra step, because here 4 is being divided by x. So we have to multiply by x on both sides first. So that's going to give us the cosine of 58 times x equals 4. Now to get x by itself, we're going to divide by the cosine of 58. So we know x equals 4 over cosine 58. So that's what we're going to have to put into our calculator in order to find the answer here. And you can just put it all in like that. So we're going to take 4 divided by cosine 58. And that's going to give us about 7.5. So we're going to say that that's 7.5. And remember, this is the hypotenuse, okay? Now we don't want to stop there, right? Because all that told us was this side, that it was 7.5, right? So then we also know that Km equals 7.5 as well, because it's a radius. So now we want to take that and subtract 4, because it asked us about Lm. So we're going to take 7.5 minus 4, and that's going to give us that Lm equals 3.5 millimeters. One last reminder, don't forget, okay, that your calculator's got to be in degree mode, right? Hit mode, arrow over, hit degree. And then you are done and ready to go. And that is the end of sine and cosine part 1.